Okay, I'd like to give more examples that demonstrate that acceleration does not cause time dilation. Okay, now the example I gave before was of two differently sized planets. A smaller, more compact planet and a bigger, less compact planet that had the same gravity at their surface, 10 meters per second squared, like Earth, but different time dilations. Okay, so that was example one. I'd like to give you two more examples that further demonstrate that not only can you have time dilation, different time dilation with the same acceleration, you can actually have time dilation with no acceleration whatsoever. Additionally, you can have time dilation, you can have a change in time dilation with no acceleration whatsoever. So hopefully these two examples will further cement the idea that time dilation is not caused by acceleration. But these other examples will hopefully give you a more concrete understanding of this as opposed to the math. Okay, so just to review the next example, we'll call it example 2, is time dilation with no acceleration. And that's going to be 2A and B. And then example 3 will be time dilation. I'm just going to abbreviate it. Time dilation with no acceleration, including a change, a change in the time dilation with no acceleration, okay? So you can actually change it. All right. Example 2A. Well, this is the most obvious one. I kind of hinted at it before. Let's say you have a planet and you have a satellite. The satellite is orbiting the Earth at a certain distance, r, okay? Radius or whatever. This satellite is in free fall. It does not experience gravity. If you were in the satellite, just like you see the space shuttle people, they're floating, they're weightless, even though they're still in the gravitational field of Earth. And the reason why they're floating is weightless is because they're in free fall. They're just following the curvature of the Earth, or the curvature of space-time. And therefore they don't experience acceleration. Now you can say, hey, they're moving in a circle, but we've been told many times, that's not acceleration. That's just space-time curvature. And it's just following the actual curvature of the Earth, and it's not accelerating because gravity is supposedly not a force, okay? So even though this object is not accelerating, okay, it is experiencing a time dilation, okay? And that's calculated as a function of the escape velocity at the orbit r, okay, of the radius r1. Give that r1, okay? And we've reviewed that before. All you do is plug in the escape velocity into the Lorentz equation, and that will give you the time dilation, okay? And it's a fixed number. It's always a constant if the radius stays the same, if it's a circular orbit, okay? Now, a second satellite at a higher radius, R2, is also not accelerating, but it will experience a different time dilation, which is a function of the escape velocity of R2. And obviously, the time dilation for 2, time dilation of 2 is less than the time dilation of 1 because the escape velocity is less the further away you are from the center of the Earth, okay? So this is an example of an object in free fall experiencing time dilation, no acceleration, okay? So not only are two objects with the same acceleration experiencing different time dilations, which was my earlier different video. These are two objects experiencing no acceleration. They're completely in free fall, but yet they're still experiencing time dilation. And again, this is because of the passage of space-time over the satellite at the free fall rate, okay? Like, as I said before. Now you can also, I'm going to give you another model with this next example that will go beyond the flow of the space-time flow model, okay? Example 2b. Okay, in this one, we're gonna go actually underneath the surface of the planet. So we're gonna take a planet and we're gonna give it a hollow inside, okay? So all the mass is in the crust, okay? And just like the center, there's no gravity at the center. There's no gravity at the center of a planet. Even though there's a tremendous amount of pressure, there's no gravity. There is no gravity inside this space if it's all perfectly symmetrical. This is because all the attractions from the crust cancel each other out perfectly. However, if a person inside the Earth, floating, weightless, in free fall, and a person on the surface, if they wanted to leave the orbital well of this planet, gravitational well of this planet, they'd still have to, now he could float over here, and then he'd have to get in a rocket, just like this guy, and blast off and achieve an escape velocity of the surface to escape. So the escape velocity for both of these gentlemen are the same, and therefore the time dilation of both of them are the same. Okay, time dilation of person A and person B are equal. And this is because escape velocity A and escape velocity B are equal, okay? Now, this is another person. Now, this person's not even moving in an orbit, so you can't even say he's somehow accelerating by circling the Earth, even though he's in free fall. This is a person just floating in the center of a cavity inside a sphere, and is not moving at all relative to his frame of reference, and therefore and experiencing no acceleration, yet he is experiencing time dilation. Now, this is interesting because it's harder to say that space-time is still falling into the thing. Does it fall through the crust and then just do circles down here, or what? So a better analogy for this is perhaps a pressure. So that even the escape velocity is not a result of the passage of space-time over the person, which was the original model, but rather it's a function of the pressure being exerted on space-time, which somehow changes the clock people experience in that space-time. And maybe someone traveling in a straight line through space-time in a velocity also experiences some sort of headwind type pressure. This is just, an idea, an analogy to help you understand, but you could view it as a pressure instead of a flow of space-time over the person, even though I do like the flow model better. Okay. Final example 3. This is another freefall model where if someone's on a planet, we have a planet in a gravitational well, we just take a person or an object, we start him out in space, and we just let him fall. And he slowly builds up speed till he hits the Earth at the free fall, at the velocity free fall velocity, right? Now, as he's falling, he's experiencing no acceleration, or he feels weightless, okay? And so he's in the true, absolute definition of free fall. He is free falling. But as he falls, his clock starts to slow. So when he starts, his clock's at the fastest. As he gets closer to Earth, he's lost this much. He's gained this much free fall velocity, and therefore incurs that. It requires that much velocity to get back out, to escape. His clock will slow down as he falls down, and as he continues to fall, his time dilation will increase more, and the clock will slow down till he reaches the Earth, and this will be the time dilation end. Okay, and hopefully he has a soft landing. But you notice he never is accelerating through this. He's free fall till he hits the Earth. Okay, so during this whole time, his clock is slowing down till he hits the Earth. Then his clock stops at a given rate or time dilation and changes no more. So when he finally starts accelerating, according to Einstein, or where the Earth starts pushing back, and that's the source of the acceleration, his clock is in a fixed dilation or rate. And so even though it's accelerating, his clock rate is no longer changing. So it's almost the opposite of what you might think, or what you would think if you thought acceleration caused time dilation. So we have now, this gives us 3 examples, or 2 more examples of time dilation occurring without acceleration. And so this should help convince you that acceleration and time dilation are completely separate. They're not related. Acceleration is just a means for changing your frame of reference, and which will change your time. But it's the actual frame of reference that dictates what the amount of time dilation is, not the acceleration itself. And there are other ways to change your reference frame without acceleration, okay? It's just a vehicle to change, but it's not the cause of the change. It's not the cause of the time dilation. All right? I hope this is helpful. Thanks.